We're back live at the Micron Exhibition Hall. I'm now here with the NASA Rover induction charging team. I'm here with Dan Matheson. Dan, would you like to talk about your project?
Yes, I would. Our project is essentially, well, as you can see behind Kelby, I don't know if you can see it, but it is a K-10 rover from our sponsors, NASA Ames. And currently the rover has a bunch of batteries on it that we need to pull apart to individually charge them and then put them all back on the rover. So what they've come to us and asked is that we create a charging system in which they just dock the rover without anybody being there, charge it, and let it drive away. So we've done that basically, and they said that we can't use physical contact, so please do it through induction-based charging.
It's really neat getting to work with NASA as an undergraduate here at the University of Idaho. How did your classes prepare you to work on a capstone project for a large client like NASA?
Our classes pretty much gave us the generalized background we need to be able to just approach the subject, and then once we were in capstone, we had a large enough engineering background we could do the research and get the little key points that we really needed to know. But the classes prepared us so we had a very broad background to understand how to approach it.
And you're studying mechanical engineering. I know that because I've had classes with Dan. I'm also a mechanical engineer. But a project like this has a heavy electrical component to it. I would imagine that you had to work with some electrical engineers. How was that interface with engineers from a different discipline?
It's a bit tricky. You have to make sure everybody's on the same page. I will say this about electricals. They look at things way differently than mechanicals do. We look at them very physical. They look at them very imaginative. So making sure we all have the same coherent thought is very key, and it takes a few tricks to make sure, several iterations to make sure we're all at the same point.
It sounds like some challenges. What were the greatest achievements that you had that were really the high points as you worked on this project for 2 semesters?
Actually, for the mechanical end was getting the ramps built, making sure seeing that our finished product actually worked, and for the electricals, I would say it was actually getting active power transfer across the coils. So we were actually able to get a voltage out on the backside of the transformer that we were modifying. So,
do you graduate in May, Dan?
Yes, I do.
What are your plans after that?
I actually landed an internship with NASA Ames this summer, so I will be playing down there near the robots all summer long.
So further work with your client, NASA, that's very good.
Slightly different sector, but yes.
What else was rewarding about this project or challenges?
Rewarding was just the teamwork. It's fun to work with a team, and it's always fun to communicate with others. I didn't know these 4 other individuals before the project started, and I now have 4 more friends.
Was this your first time doing design work as an engineering student here at the University of Idaho?
On this scale, yes. We did little projects in other classes, but by far this is the true design test to see if you can put all your knowledge to work.
When did you start on those smaller scale design projects? Freshman year, sophomore year, all throughout the curriculum?
Freshman, sophomore was the main focus, 123, 223.
So students coming to the University of Idaho to study engineering will have design experience from the get-go?
Oh, yeah. Lots of it.
Well, thank you very much, Dan. We're going to take a brief pause, and we'll be back with the McKinley Elementary School, some civil engineers who worked on a school in Boise. Thank you.